Hi, this is the Foundation Tier Waves revision video. So some facts you need to know about waves. All waves are made by vibrations. All waves transfer energy. The wave travels, but the particles does not. Remember, that's true of all waves. Waves that look like this, which is a transverse wave, have peaks, sometimes called crests, and troughs. The amplitude is the distance from the top of a peak to the rest position or the undisturbed position. That's this horizontal line. The wavelength is between two matching points, so peak to peak, middle of the wave to the middle of the next wave, or trough to trough. Transverse waves have vibrations that are perpendicular to the direction of the energy transfer. There are lots of examples of transverse waves: water waves, microwaves, visible light. Longitudinal waves have vibrations parallel to the direction of the energy transfer. There are very few examples you need to know at GCSE for this. They would be sound and ultrasound. Longitudinal waves have different labels than transverse waves. They have compressions, which is the squashed together section, which can be shown in these areas, or rarefactions, that's the stretched out bits. You have to learn the wave speed equation. Wave speed is frequency times wavelength. Very fatty lamb. This symbol here is the lambda symbol in Greek, and it stands for wavelength. Wavelength must be in meters, frequency in hertz, and wave speed in meters per second. The time period equation, time is 1 over frequency, is a given equation on the formula sheet. A key definition to know is that frequency is the number of waves that pass in 1 second. So 1 hertz means 1 wave per second. 1 kilohertz is 1,000 waves per second. There are a number of required practicals in this topic, one being the ripple tank. So what you have to do for the ripple tank is set the ripple tank to produce waves, adjust the height of the lamp so the waves are visible below the tank, ruler to measure the right angle to the waves, measure 10 waves using a ruler, divide by 10 to get the wavelength, count how many waves pass in 10 seconds, divide by 10 to get the number of waves in 1 second, which is the frequency, and then you can do frequency times wavelength gives you wave speed. Another version of that practical is waves on a string. So you attach a string to a vibration generator over a pulley, to a weight, you adjust the frequency till a standing wave is visible, measure the wavelength using a ruler, repeat steps 2 and 3 for different waves, and again, calculate the wave speed using frequency times wavelength. The electromagnetic spectrum is a continuous spectrum wave of a transverse wave. It travels at the speed of light, it can travel through a vacuum, and it can be absorbed, emitted, reflected, and refracted. The examples of electromagnetic spectrum are radio waves, microwaves, infrared, visible light, UV, X-rays, and gamma rays. You need to be aware that they are long and low at this end. So long wavelength, low frequency, low energy, so not very harmful to humans. And then this end, the shorter wavelength, high frequency, high energy. Do remember that the high energy waves do not travel any faster. They just carry more energy as they travel. They all travel at the speed of light. You are needing the uses, so radio waves for radio signals or Freeview channels, microwaves, mobile phone signals or satellite TV, infrared remote controls and thermal imaging cameras, visible light, fibre optic cables, cameras, and allowing us to see, really. Ultraviolet, sunbed, energy-efficient light bulbs. Think about your banknote forgeries as well. X-rays, detecting broken bones, and gamma rays, treating cancer. You also need to know the dangers. So most of them have no dangers, burns, then damages eyes. Ultraviolet causes skin cancer, not just cancer. Both X-rays and gamma rays can also cause cancer. Leslie cube is another required practical. So you have a cube with 4 different sides coloured differently. Here are the sides: matte black, shiny silver, matte white. You place the Leslie cube on a heat-resistant mat to protect the surface, fill with boiled water, put a lid on, and then use an infrared detector to see how much infrared radiation is emitted from each surface. What results you will find is you will find that the hotter objects emit more infrared. So the best emitter would be the matte black, matte means dull, and the worst emitters would be silver. However, the silver surfaces are the best at reflecting infrared radiation. Remember, the hotter an object is, the more infrared that is more infrared that's emitted. Refraction happens when light goes into a different medium. When I say medium, I mean substance like solid, liquid, or gas. So the instant ray goes into the block, so it goes from air to glass. It then bends towards the normal because the light slows down, this angle is smaller. And as it leaves the block, it bends away from the normal as the light speeds up. Remember, the dashed line is called a normal and is at 90 degrees to the surface. That's the end of the waves topic.